W1VLF.
Hey everybody, my name is Paul, W1VLF. Thanks for coming back to the lab here. Today is going to be part 2 of building the WWVB antenna. And a couple things that we'll cover. First of all, sorry it took so long. Things have been just really hectic and I have not been able to get out to the shop here. But thanks a lot for staying with me on this one. I appreciate it. Today we're going to cover the parts list to build the housing, to build the actual coil, the ferrite rods, all that stuff. We're going to wind the coil. We're going to look at how much inductance we end up with, what we need for capacitance to resonate it, how we sample the signal from the resonated coil. And we're also going to look at the evolution. I put together like a little PowerPoint thing, and it'll show you how we go from a coil to a ferrite loaded coil to resonating it, sampling it, what exact values do we need, and how close do we come to those when we're winding these components. So that if you change some things in this design, you'll at least know a direction as to how to get back to making it work. The last part of this video is going to be actually tuning the antenna. We have basically the core of the antenna here right now, with the sample winding here. It's going to be mounting it in the housing. Okay, getting it mounted in the housing here, bringing the wires out, and how we get to get this T together and all the right lengths. All that stuff will be in the parts list. And then finally, we're going to tune it up. Show you the procedure for doing that with your laptop and your SDR. I use the Discovery because it works really well. It's nice and small, light, easy. Take it portable with you, all that neat stuff. And then we're going to do a remote test. We'll stick it out, not on the bench here like you're used to seeing this, but out on the out in the antenna field, 300 feet away from the house. So we'll get to see what it looks like coming through that coax cable 300 feet, and also in a nice quiet environment. So anyway, I'm not sure how much I have for this opener here. Anything else? Well, I do have all the components, the PVC pipe and the T and the end caps and everything, and all this is described in the parts list that we'll go over there in a couple of minutes. The parts list, it covers where to get the ferrite rods and just about everything that you need to know. What it doesn't tell you is where to get this number 24 wire. I use number 24 because I have about 25 pounds of it on hand. If you use number 22 wire, a little bit bigger in diameter, you're going to find that you have less turns. The 15 millihenries of inductance will not be there. It'll be a little bit less because your wire diameter is bigger and you have less turns. But using the calculator that we'll show later, you'll be able to figure out how to know approximately what capacitance you're going to need for this. So I guess I rambled on long enough. I guess we're going to move into, the funny part about doing these videos is you can't do them in order. You have to do all these different segments and then try to put it in order. So being an OB and an old bastard, I sometimes can't remember what I said in the previous piece, so bear with me on that. I think we're going to move now into winding the coil. And the end part will be kind of the tutorial of how this thing ends up being an antenna and kind of an evolution. Okay? Thanks a lot. Let's move along. Okay, so in this part of the video, we're going to glue up the essential core here. So I've got, let's see, 16 inches. 16 inches of the half-inch CPVC. You'll see this in the parts list. 2 end caps, one of which I drilled a small hole in, and that's going to be for later on. It's going to serve 2 purposes actually. For later on when I wind this coil on the lathe, and it'll also let the air escape out from this tube when we do this glue up. So right now what I'm going to do is I'm going to glue the permanent end on with the PVC cement. And then I'll do a little bit of a close-up and show you what's going on with the two cores here. You can use multiple cores. You can stack cores horizontally, lengthwise. What's going to be critical is when we get our big coil wound is that nothing moves in relation to anything else. Even if there's a 1/4 of an inch gap in between these two, they don't have to be making an actual electrical contact as long as that gap doesn't change. You know, we can't just put the two cores in. And also be really careful. You drop one of these even from 6 inches on a concrete floor and it's gone. There's no getting around it. So there's a little bit of play in there because I haven't put the cores on tightly yet. But what I'm going to do is we're going to put a little bit of glue, Gorilla Glue. I think it's, I forget what the name, what actually it's called. I'll show you the bottle. But it expands. And so this little hole, when we get the cores in there, is going to let the air out and probably some of the glue too. But what's important is that wherever those cores land in there, that they don't move. So do a quick glue up here, show you that part, and then we'll move on. Okay, so here's that glue I was talking about. It's Gorilla Glue. Bonds virtually everything, but it's one of those expanding glues, and you need a little bit of water to make this work. I've already put one end on the PVC pipe here, okay, and so my end with the hole in it is yet to go on. So what I'm going to do is I'm going to put a few drops, maybe a little bit more than that, down the center of the PVC here. When it finally gets, by the time it finally makes it to the, okay, alright, wipe the end of that off, and then I'm going to kind of wet up my cardboard here so I don't mess up the Group W bench any more than it already is. And when these go in, they'll kind of slide in slowly, right, and I probably put a little bit more in there. And the whole reason for this is, again, this is that expanding glue. Okay, and we'll wet this up a little bit. Okay, twist it. Okay, you can see that goes in slowly now. This end here is pushed on all the way too, this far end. And so the only thing really left to do is to glue this, glue this up. Clean that out so we make a good connection and push it on nice and tight. Okay, and I'm going to push this down so it's very tight. Okay, so you can hear already that it's not really moving. Okay, so that little hole is for expansion. That's to let air out. And you're going to end up with some glue on the end of this from the expansion, but just clean it up. So the only thing left to do now on this is to stand it up for a couple hours in a vertical position. Well, you know how hard it is to look at a tiny little screen and hold all this stuff in the right spot? Anyway, I put it in a vise right here, and I just let it stand. I don't squeeze it a lot, just enough to keep it vertically, and then we're done. So next step is going to be winding the coil, but I've got to let that glue expand and cure. So I'll be back after that's done. It's going to be a couple hours, but for you it'll only be a couple minutes, or even less. Okay, so we're out at the lathe, and this is the way that I wind them because I have access to a lathe, but also because when I was making 10 or 15 of these at a time, it got very, very cumbersome. So here's where that tiny little hole is going to come in handy. I'm going to put it in between the chuck here, and let me just tighten up the chuck a little bit right there. Not enough to crush it, and we'll put the center So now we have a nice tight arrangement. I left about 5 feet of wire here on the end I'm going to wind from, because we're going to need that to go down inside the housing and come out. So we'll leave that there. The chuck is going to be turning away from us like this. Actually, you know what? Let me just pull that out of there just a little bit more. Let's get that out of there just a little bit. Right about there is probably good. Okay, so that's a center that's going to allow it to spin. This is going to be what we drive from. By the way, don't ever leave that in there like that. That was a mistake on my part. You forget that in there and you turn the lathe on and that chuck key will come flying out. So I'm going to be winding in this direction where the chuck is moving away from me. So I'm taking my extra piece of wire and I'm going to wind it around the chuck here. Alright, to get that out of the way. Alright, yeah, just fold that under so it won't move. Okay, and away we go. It's always a little bit nerve-wracking when you first start it. You want to make sure that the wire is feeding properly. I think there's about 800 turns. So it's possible to do this by hand. But not much fun. So as I come up to the end here, I'm going to have my hand on the power switch, and right when I get to the end, I'm going to shut it off. Okay, good. Hold that in place while I rip off a piece of tape with my teeth. That's very professional, isn't it? Just tape that on there temporarily. Okay. Alright, we're going to need another couple of feet extra on this end too, so we'll break that wire off. Okay, and I'll just run the lathe for a couple seconds just to wind that up. Okay. Alright, so now we have to tape this down. So I'm going to start with the tape over here. Get it relatively tight. Give it 1 or 2 turns by hand here. Okay. Let's see, back it off a little bit. Okay. All right. So, we're done winding. So I'll unwind this piece here. Okay. And we'll unchuck this from the lathe, the 3-jaw. Okay. And there's our finished coil. This will carefully undo. And now we'll go over to the bench and we'll check this on the LCR meter to see we should be somewhere around 11 millihenries. All right. Okay, we're over at the LCR meter, actually a couple of LCR meters. One hit, if you're interested in experimenting with this kind of stuff, it's really handy to have an LCR meter. These are quite old. There's a lot of very inexpensive ones out there today, but being able to measure L and C with reasonable accuracy is really cool, and will help you in a lot of your experimentation. So here's the coil. Okay, I had to do a quick edit there because holding the camera and connecting the wires was a little difficult. So just some 4-wire leads here and back up, and you could see the estimate was 15 millihenries, and we're at 14.5 millihenries. So we'll pop that number into our calculator afterwards and see how close we come. While we're over at the LCR meter, I thought I would take this variable tuning capacitor that I have. This is how much capacitance it takes to resonate that loop to 60 kilohertz. So I'm going to bring that over to the LCR meter and check real quick the value of that, and then we'll have both values to plug into our calculator. Okay, so we're over at the calculator here now. There are lots of different electronic calculators out there. This one seemed to work out pretty well, and it also shows the LC circuit at the bottom. So, of course, you have all your obligatory commercials and whatnot here. So, but let's roll down to the meat of the program. So when you first fire up the calculator, it calculates something evidently in the audio range. But so our inductance, we want to be what? Let's see, 14 point. Let's call it just 14.8, and not microhenries, but we were in millihenries, so we'll select that. And we had about 480 picofarads, not microfarads. So we'll go to pico, and we want our answer to come out in kilohertz. So let's hit the calculate button and find out where we are. Okay, so 59.7 kilohertz based on our actual values of 14.8 for the coil and 480 PF for the capacitor. So this shows us that we're in the right ballpark. Part number 3 of this video is going to be the actual tuning, which may be the most difficult part for people to do, and I'm going to try to show that by using it to tune the noise floor. But this allows you to say, I have this coil of this inductance, this amount of capacitance, where am I going to land here? And vice versa. You could say, I think you can in this, 60. Let's see, let's do this 60 kilohertz in kilohertz and calculate again. Well, you have to get rid of one of these values. So turn that back to 0. Calculate it. 475 picofarads. It's now calculating that value. So you can run the calculator a couple of different ways. So if you can measure one or the other, you'll know what the third value is. Anyway, back to the video. W1VLF signing out. Wanted to take a couple of minutes and show how this antenna evolves. And in the first slide here, you have basically just an inductor, raw inductor. And this is the 16-inch inductor that we wound over on the lathe. Right now there is no core in it, and I really don't care at this point. What we're interested in is what we end up with when we wind those 800 turns. In each one of these, you'll see a red arrow showing what we changed from the previous slide, and in this one we've inserted the ferrite core, and now we're going to measure that, and at the bottom of the screen you can see 15 millihenries, which is the size of the inductor, the inductance for this antenna. The next component added is the variable capacitor at 480 picofarads. That value I determined empirically from building these over the years, but as you saw in the previous parts of this video with the calculator, that component can vary based on the amount of inductance in the coil, and so you can arrive at that using that calculator. It gets you in the ballpark. Here it ended up being 480 picofarads. I show it as a variable because that's what That's how I tune the antenna to the exact frequency. Later on, I would measure what that capacitor value is in real world, what the capacitor value actually is, and then I would build that with silver mica capacitors so I wouldn't obviously have a variable capacitor out inside that housing. So now that we've built our parallel resonant circuit, and that's really what it is, the only difference between this parallel resonant circuit and one that you might find inside of a radio is this one is designed to receive frequencies, to let the radio frequency magnetic fields cut into it and give it an output voltage. And if that's the case, we need to extract that energy somehow, and we do that with 10 turns of wire in the very center of the core. I've tried 20 turns, less turns. You can change that impedance transformation and the return loss, but to get the proper bandwidth that we're looking for and to extract as much signal as possible, 10 turns seems to work really well. Alternately, you could tune this antenna and put it near a receiver that already had 60 kilohertz, small 60 kilohertz, like an atomic clock antenna or something like that. And if as long as it was in the field of this resonant circuit, that would work as well. I've done that quite a few times in the medium wave bands. But in order for us to extract that signal and then put our antenna out at 300 feet, we need that coupling loop. In this slide, we just show that the SDR receiver, whatever you're using, or even standard receiver, is coupled to those 10 turns. Not much really to report on this slide here. Whoops, quick note, look there, it says 11 millihenries. That really should be 15 millihenries. Quick slide here just to show the various components that are used in building this antenna. They're called by their generic names, not by any particular company's part number. This way here you can go to either Home Depot, Lowe's, Menards, or wherever you're going to get your PVC components from, and just look for these pieces. A few more things you'll need here: the ferrite rods, and these are the 10 millimeter by 200 millimeter 400 permeability Russian surplus knobs. Russian surplus rods. There's a lot of different companies from over in China selling the same diameter and length. I've never used those, so I don't know if you put those into this circuit if that'll work. I bought a ton of the Russian ones, and they've always seemed to work. They're not they're not cast that well. They're not perfectly straight, full of little lumps and bumps, but you're never going to see that when it's inside the housing. An SO239 UHF chassis mount has to be the 4-hole type, because that's going to be important when we put the end of the antenna on, and it will hold that connector in place and shield it from the weather. That's important. And then the third is I use number 24 wire, which, if you don't know if you have number 24 wire, it's approximately 20 thousandths in diameter, and you need about 120 feet of that. You could go through the calculations. There's about 800 turns at 20,000 20 thousandths diameter per turn, and the rod is, I think, the CPVC is something like 5/8 or so in diameter, and do the pi formula and come out, but you're roughly going to need 120 feet for the antenna. A lot of turns. Here's a screen capture from eBay showing the actual rods. I think this is even the person I bought these from. Although they're a lot more expensive than they used to be. These are the either Russian or Ukrainian knobs that, I keep saying knobs, rods that came on the surplus market. These I know will work in this antenna. The other ones that claim to be exactly the same from China, try those at your own risk. I really don't know if they're going to work or not. Here are the dimensions of the pieces of PVC pipe. Everything on this page is 1 inch. and you can see basically how it goes together. I'm not going to show gluing the whole antenna together. That's pretty straightforward. Anybody who's played around with PVC pipe understands that. But you can look at this page, and then you can go back to the parts list and order up what you need. So 2 pieces of 1-inch PVC, 8 inches long. There's the T, the 2 end caps, the male and female adapters, and then the PVC pipe at the bottom, and then another little section of 3-inch long 1-inch PVC. Parts list for that inner core, just a single piece of the 1/2-inch CPVC with a couple of end caps and 16 inches long, and that's the where the ferrite rods go inside of and what we wound our coil on. Just a quick note here, the antenna will be broadside toward WWVB, not off the end off the end caps. So when this thing finally gets orientated, it'll go almost east-west for me here in Connecticut. Okay, that's it for part 2. Appreciate everybody sticking with me this long. Part 3 is coming up, and in part 3 we're going to be tuning the antenna, mounting it in the housing, and then doing an on-air test with it located 300 feet out in the woods, so we can see how the antenna will perform then. If I can ask you please to subscribe and give me a thumbs up on this video. I think if you give a thumbs up, if you enjoyed it, that it will get promoted to other people. It's a big incentive to do more of these things. Thanks again. This is W1VLF, and I'm signing out.